Sir,
Yes, I'm
sir, we're
asking that.
done with the entire thermophysics.
Mm-hmm.
I'm saying, are we done with the entire thermophysics?
Yeah, yeah, entire
Okay.
thermal physics. Because temperature has been excluded. That is not the part of your syllabus right now. Okay, that's why temperature topic is not there. Okay, so today we are talking about general physics, general properties of wave, yeah, general wave properties. So in this one, first what we have to discuss about, we have to discuss about the wave motion, terms included in the waves, and wave behavior. These are three main categories of our topic of general properties of the waves, right? And I hope that it would be quite convenient for you people. Okay, so let's start with that. When we talk about wave, so describe what is mean by a wave motion when we consider a wave other than the particles. So what a wave is, can anybody tell me, regardless of this what I have written on that, what a wave is?
Mm,
Yes, Meera.
Mechanical energy. Okay.
Oh, yes, 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 you can start. Yes, if you are starting, then continue.
Well, mechanical energy transmitted from a medium. Okay.
Yes, Hassan, what is your opinion about the wave? Yes, 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 come on, hurry up. बताइए वेव के बारे में आपका क्या आइडिया, आई मीन हाउ कैन यू इलेबोरेट द वेव के यार. For example, if you have to make someone clarify that, oh, I am talking to you regarding waves, so what a wave is? Yes, Meeram.
Sir, same patterns that are repeated in a motion.
Okay, wow. And the last is Ariba. Yes, आप बताइए.
About what a wave is,
Yes.
I I think it's like some sort of disturbance that moves in an organized pattern.
Wow,
And
wow, perfect. But why you are so hesitant to read it out?
just a bit unsure, that feeling that
Oh,
perhaps I'm mixing it with something else.
no, that's perfect way to describe a wave. ठीक है, Hassan? Wave is basically the propagation of energy in a periodic manner, right? It is basically the propagation, or mean spreading out of energy. Got it? I will explain that in detail. Propagation of energy. Yes, yeah, yeah, you were right. But you have just classified a specific type of energy, mechanical energy. Yes, we can. Propagation of energy.
Oh yeah, I forgot light.
Yes, due to uh, vibration of particles, right? I will add this word over here. Vibration of,
What is vibrating in light?
yeah, we will talk, or I will check, I will say that it is due to vibration of medium, actually. Whatever there is a medium, in electromagnetic waves, we consider that uh, some medium is existing. For example, photons are there and they are carrying that wave. So, by the vibration of medium without transfer of matter. This is very important in that. You cannot transfer matter in waves. Okay. For example, I will go to the other slides. Everything would be explained to you, inshallah. This is a rope, and I have hooked up a nail from my at the wall with this rope, or I am going to have a ring attached with this rope, and that ring is at the wall. So, what do you think? When you are holding this rope from this point and you are going to jerk this rope up and down, so the particles which are in your hand, they are in your hand forever until you are holding it, but those particles are transferring energy right? And finally you will see that this ring is moving up and down. Did, do you realize this what I'm talking about, or can you imagine that? Particles do not travel in that one. I mean, those particles which are in your hand, they remain in your hand, but those particles transfer energy to the next, 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 and so on. And finally, they are able to transfer the energy to this ring. So here we go. That describing a wave. A wave is a phenomena in which energy is transferred through vibration. Okay, I will answer your question, Yaya. Your question is very valid, but this is not the stage to answer that question because I would be diverted from my topic. That's why. But when I will reach to that point, inshallah, I will answer your question. Okay, and that question, I mean, that answer will be in your electromagnetic waves. When I will reach over there, I will talk to that. Got it? So a wave is basically phenomena in which energy is transferred through vibration. A wave carried energy away from the wave source, right? So this is that example what I have shared with you, that this is our hand. You are going to vibrate this wave up and down. Sorry, vibrate this rope up and down. And energy is being transferred to the other end or to the other side. So similarly, if you have some springs in your hand and you are going to transfer energy to the spring, if you are going to vibrate it back and forth, you will feel that energy is transferred in these type of pulses over there, right? But if you jerk it up and down, you will feel that yes, energy is transferred in such a way that these are moving up and down. So this is basically the general concept of wave what we produce in our daily life. But when we talk about waves, the most important thing is the water. यानी हम लोग बात करते हैं कि यार waves, where the waves are. So 99.9% brain strikes to the water waves, is it? Or sea or ocean. ऐसे है ना?
Yes.
So check this one out. There is a water wave. I mean a pulse of water. It has a ship or a boat over it. It is ridden. Then what happens? This wave or sorry, this ship or boat is vibrating up and down. Check this one out. These are three different snapshots. So this is vibrating up and down, but it is not moving forward until unless you're not going to operate your engine or whatever you have its mechanism behind it. But this wave is passing on, right? And it is causing the particle to vibrate up and down over here. So this is another mechanism of the wave. So when we talk about this all, I generalize this concept that when we have here, we will talk about some wave terms, right? Terms including the. So first of all, I will talk about wave front. Did you see that when I'm going to disturb water over here, that water is spreading out, or that disturbance is spreading out in the form of ripples? Did you ever notice this mechanism?
Yes.
Yes. So actually, what is happening? The source of disturbance is there, the finger that is dipping into the water, and circular wavefronts are being produced. And those wavefronts are actually they are called wave fronts. What do we call them? Wave fronts. So wavefront are those imaginary lines which are basically, yeah, here that is very obvious. When you vibrate a dipper horizontal back up and down, so what to do? You are producing the waves. So these are all peaks. If you notice down, these all are the peaks. So I am joining all the peaks of the waves. So wavefronts are those lines which are produced due to joining of peaks of the waves. For example, देखो, if I have a wave like this, I have wave number one in this way, wave number two in this way, right? And I have peaks of all those waves in phase are there in the same direction of motion. So I am drawing a line which is to join all these peaks. Okay, so these are the wavefronts. Is it clear to all of you? These are
Yes.
your wave fronts, the lines which show the identical position of a wave, the lines which show identical positions of waves, especially peaks. We basically join peaks, so that is called wavefront. So remember this thing, these are the straight wavefronts, and if you have ripples, these all are also wavefronts, and these are circular wavefronts, right? What do we call them? Circular wavefronts. Okay, now let's talk about, define the term speed, frequency, wavelength, amplitude, and calculation by using v is equals to f lambda. This is a major portion what we will discuss, that there are so many terms which are basically added together, which are being used for the calculation. The highest point of the wave, the highest points of the wave is called crest or peak of the wave, while lowest point is called trough of the wave. Is it easy to remember or not? If I have a wave here, I have shown all of these things in your, in the given in the next diagram. So just remember this thing, that highest point is called your crest. So this is your crest or peak of the wave. Similarly, this is your crest, and lowest point is called your trough. These are basically troughs, right? Is it clear to all of you?
Yes, sir.
Okay. Then we will talk about some other properties. Those are, what are those properties? The amplitude A is the maximum displacement for the from the rest position. Simply speaking, height of the wave. No one can penalize you. Height of a wave. That how much height a wave covers or travels from the main position. So actually, when I draw a wave on the same page, बार page नहीं vary करवा रहा. So this is called its amplitude. What do we call it? Amplitude, because this is the main position. This, let me draw it with a different color. This is the main position, right? It is called equilibrium position, or it is your mean position. What is that? It is your mean position, right? This is your crest, this is your trough, this is your crest, this is your trough, this is your crest, and so on. So amplitude is the distance between peak and equilibrium position. Then wavelength is the distance between two consecutive peaks, or distance between two consecutive crusts or troughs, or distance traveled by one wave. So simply speaking, it is length of a one wave. So what is wavelength? Lambda. It is length of one wave. Length of one wave. Then we have, it is equal to distances between two identical points in successive waves. So I have explained that all over here. Then we have, yes, in this diagram I have shown you the where the amplitude is, what is the wavelength, and one wavelength is that, so its length is one wavelength, lambda. Okay. Then we have to talk about that time period is the time taken for a wave to complete, time required to complete one wave, right? Time required for the completion of one wave, you have to remember that. And this is the time taken for from one crest to the other crest. That's very simple, right? Or the distance moved by one wavelength. You have different ways to remember that. Okay, the frequency is number of waves that are produced by a source. So here, time period is time required for one wave. What is time period? Yes, time required for one wave. Time required for one wave. Required for one wave. Remember this thing. It is represented by T. What is frequency? Frequency is number of waves per second. Frequency is frequency is number of waves divided by time taken. That's it. Time taken. You can use this formula as well. For example, you are producing 100 waves. How many waves? 100 waves in 5 seconds. In how much time? 5 seconds. So what is the frequency of the wave? Frequency means
Frequency
repetition
per
time. Yes, it is 20 waves per seconds. 20 waves per second. So it means number of waves per second is called the frequency. What do we call it? It is frequency. So simply, when we are talking about frequency, frequency is how many waves are produced in given time. So simply, if there is one wave and how much time it takes, if I revert that, I can calculate this, or I can say that. मैं एक और फॉर्मूला बनाता हूँ आपको. F is number of waves divided by time taken, small t. So this is the true formula for your frequency. But if I make a formula for time period is time period is total time divided by number of waves. For example, if I say the total time taken for those waves was 5, and in that 5 seconds 100 waves have passed through a point, so what it will be? 0.05 second, is it? So it means if 5 waves are passing in 100 seconds, one wave is passed, or one wave in how much time? In 0.05 second. Is it clear to all of you? So if you relate this equation with this one, what I have written in the black, so are they not inverse of each other? If I say time period is, check this one out. If time period is, इधर कर लेते हैं. If time period is time for, sorry, total time divided by number of waves, and frequency is number of waves divided by total time taken. So can I say that frequency and time period are inverse of each other? Check this one out. Can I say this?
Yeah.
Yes, exactly. That's why you have an equation. Frequency is 1 upon time. Remember this. This is very important fact. You have to recall this equation as well. That frequency is 1 upon time. So is it fine? Will you be able to know that? So if your x-axis is time period, okay, then the distance between a time taken for one complete wave is your time period. Okay, t.
Yes, sir.
Now I have an equation. This is a very, very important equation. Very important equation. V is equals to, you know what is speed? Speed is equals to Ariba. I will be glad to know the equation of speed from you. Normally, what is the speed equation?
I'm quite sure it's distance over time.
Very good. Distance over time. Mirab, what is distance in this case?
Speed into time.
No, no, no. Distance in terms of wave. I'm just specifying this. Distance for one wave. Distance by one wave. I'm going to specify that formula for waves, and time for one wave. So, can you interpret that in terms of wave? Hassan?
फिर क्वेश्चन की समझ नहीं आ रही.
क्वेश्चन ये है कि मीरब ने फॉर्मूला बताया, सॉरी अरीबा ने, कि स्पीड इज डिस्टेंस डिवाइडेड बाय टाइम, राइट?
जी.
मेरा क्वेश्चन ये है कि व्हाट इज डिस्टेंस ट्रेवल्ड बाय अ वेव एंड व्हाट इज टाइम टेकन बाय अ वेव? Distance
Distance,
traveled by a wave is what?
wavelength,
Very good. Wavelength. And time taken for the wave is
time period.
time period. Well done. So, can I say that V is equals to lambda divided by capital T?
J.
Yes. So, yeah. If I say this thing that V is equals to lambda, so can I write it as 1 upon T separately?
Yes.
And again, Mirab, is this 1 upon T is equals to frequency?
Yes, sir.
Sure.
Yes.
Okay. So, Ariba, is this derivation correct according to your opinion? Is there any flaw or incorrect step in that one?
Sir, actually, I had to ask you if you could explain it to me again.
Okay. Listen, you told me, I don't know, why did you tell me this distance divided by time? I'm just following that instruction. That speed is distance divided by time, right? But as I am interested in the distance traveled by a wave, so Hassan told me that distance traveled by a wave is your wavelength. Okay, so I am agreed. And yes, Hassan told me again that time taken by one wave is the time period of the wave. Got it? So are
All
you
right.
agreed? Okay. So I just put those notations over here that speed is V and wavelength is lambda and time period is capital T. Okay.
Okay.
You got it? बात समझ आई अरिबा?
G, sir.
Okay. अब देखो lambda is same, just put it as it is. Then I just wrote 1 upon T separately. Yeah, agreed with me that yes, you can write it because lambda into 1 will be lambda divided by T. So it would give you the same expression lambda divided by T. So no problem. But I told you that 1 upon T was basically frequency in my previous slide. Is it?
Right.
So 1 upon T is substituted as frequency. So simply you have to remember this equation. This is your destination, right? But it is not hard to now or hard to learn this equation as well. So these three parameters V, lambda, and T are related with each other in this way. Okay. And then you have two other parameters V is equals to F lambda in this way. Will you be able to remember that or recall this equation? All of you?
Inshallah.
Yes.
Yes. It's quite easy. And this is the one equation which is being used in your wave equation. कोई issue नहीं है इसमें. Okay. Now displacement and position graph is displacement position graph mean the particles are vibrating up and down, and this will give you the distance along x-axis. So okay, अब check करो. If I say distance between two consecutive crests is called a wavelength. Okay, this is a wavelength. This is a wavelength. I have mentioned this all for you people in my previous slide. Okay, this is the amplitude. This is the amplitude. Again, this can be amplitude and so on. So those all are actually represented over here in one way. So same, if your x-axis is time period, then the same length will give you time period, not wavelength. देखो ये problem है यहाँ पे. If you will not see the axis, you will be trapped. But height would not change. Height is same as amplitude. Okay. Now we have different equations. The varying system produces a wave of this much frequency. Frequency का unit hertz होता है. Sorry, I did not tell you. If the wavelength of the wave is this much centimeter, what will be the wave speed? So how to handle this one? using V is equals to F lambda, the one and only tool you have. So F is 25 hertz and lambda is 1 centimeter. Remember that you have to convert it. It is 0.01. So it would be 0.25 meter per second, isn't it?
Yes, sir.
Got it? Clear है ये?
J.
Right?
Yes.
Here you have wavelength and speed. You can calculate frequency. A tuning fork is the frequency is given to you, speed is given to you. You have to calculate wavelength. So it's very, basic level. So I think we have to switch the slide. Just it's quite easy for you. 10 waves are passing through a point in each second. Time is given to you. Number of waves are given. Yes, that's why I have provided you that equation. Wavelength is 30 meter. What is the speed of the wave? So for speed, what do you need? I'm solving this one. You have V is equals to F times lambda. And you know what is F? F is number of waves divided by time taken. Isn't it? That's why we have selected that equation. मैंने आपको पढ़ाया ये. So what is N? N are 10. Yani how many waves are there? 10 waves and time is 1 second. And what is the wavelength? Wavelength is 30 meter. So it means its speed is 300 meters per second. Are you getting this thing? Is it clear to all of you?
Yes.
Okay, so these type of questions will be asked to you. I will switch to the next. I will send you this slide. So I hope that you will be able to handle these questions. For example, a radar is an electromagnetic wave. Sorry, yeah, a radar wave is an electromagnetic wave with the speed of this. Its frequency is this. Find wavelength. So it's very easy. I think you have plenty of knowledge to solve these all, right? So here we have to talk about some of the waves. Basically the diagram shows a ball floating in a tank of the water. So direction of the wave is given to you. So basically which diagram shows the movement of the ball and wave passes? So I told you that in water, basically the water waves vibrate up and down. So that would be the right option. Okay, so what is mean by term wavefront? So I told you that a line joining all the points along the peaks of the wave. So these are basically those MCQs which are based on the knowledge you people had already. Yes, that is that. A vertical stick is dipped up and down. This is a past paper exam question, right? A past exam paper question. At point B, in 2 seconds, 3 wave crests are produced. In how much? In 2 seconds, we are able to produce these crusts from the surface of the wave. So which statement is true? Distance x is the amplitude of the wave. Okay, check the diagram. Yeah, this all question is in front of you. This distance is amplitude of the wave. Distance y is wavelength of the wave. That y. Each circle representing a wavefront. Frequency of the wave is 3 hertz. So who will answer that? Hassan?
Uh, A.
Okay. If you remember, I told you that wavefront is basically the distance between consecutive peaks like this. And in next slide, I told you that this distance is actually a lambda. What is that? It is one wavelength. So if there would be a circular wavefront, definitely this would be your one lambda. Is it? Now go back to the question, all of you, from these clues.
Yeah, it is C.
Yes. Yeah, yeah. How did you know that, man? Mirav, are you agreed?
What do you say?
I mean, which option is correct for this one? For the top diagram.
C.
See, Ariba, are you agreed? Hassan?
J, sir.
check करो देखो,
Yes.
this is one wavelength, so it is lambda, right? It is two wavelengths, so it is not a lambda. In option it is given that is a lambda, and each line is a wavefront, right? It is mentioned over there, so wavefront nahi hai. So that's option was basically uh, option C. So which is the best description for the speed of the wave? The distance between one wave crest and the next, distance between crest and wave trough, sorry, the distance that a particle of the water moves up and down in 1 second, the distance traveled, a distance that a wavefront moves along the surface of the wave in 1 second. So what's your opinion, what is the speed of a water wave?
D.
D. Yes, you're right. Very good, yeah. Okay, so these are the basically questions which are related to your discussed uh, information what we have discussed right now. Okay, this was one of the different question. The dipper in the ripple tank vibrates with a frequency of 4 hertz. This is the frequency, and resulting wave patterns are photographed. The distance between the two crests is shown in the figure. It is not two consecutive crests, it is just two crests. What is the speed of the wave, right? So there, the knowledge behind this question is, this is one wavelength, this is two wavelengths, this is three wavelengths, it is four wavelengths, and five wavelengths. So it means five wavelengths are equals to 20 centimeter. So one wavelength is equals to 4 centimeter, which is equals to 0. Sorry, answers are in centimeters per second, so no need to convert, right? So which formula we have to apply? V equals F lambda. Okay, and F is your 4, and that is your 4. So it is 16 centimeter per second. Remember this. This was a trick in that question. Okay, is it clear to all of you?
जी.
Yes.
Okay. Again, these type of questions are there. Don't get nervous like this is a snaky diagram. So the diagram shows a part of the spring that is shaken from the side to side to produce a wave, right? So it's the distance between two crests is given to you 0.6 meters. So what is that? Isn't it a lambda? This is frequency, right? And how long does it take for a wave to travel 3 meters? So it means we have speed over there, right? From these two parameters, can we calculate speed? V is equals to F lambda. Mirab, are you getting this thing? Ariba?
Yes,
Yes,
sir.
sir.
Okay, so frequency is 2.5, and what is wavelength? 0.6. So what will be answer? $15. Calculator nikalo shabash. Okay, so speed is basically, speed is equal to distance divided by time. This is two-stage question. First we have to find speed, and then we have to find time taken. So from here, time is equals to distance divided by speed. So
Sir,
distance is 3
1.
meter. Sorry?
1.5.
Oh, sorry. 1.5 meter per second. So 3 divided by 1.5. So your answer should be 2 seconds. So option should be C. So these type of questions are actually from the same equation, but they are a bit, different questions. A bit difficult question, not too much. So is this question clear to all of you?
Yes, sir.
Confirm?
Yes.
All of you means all of you. I have to consider one yes, sir, so I will move on. Okay, let's talk about the types of waves. Okay, now this is the second aspect of the waves. I would like that most of the topic should be covered today. So we have to discuss about longitudinal waves and uh, transverse waves, right? It is actually the topic under the topic of wave behavior. What is the topic name? Behavior of the wave. So when we talk about transfer waves, so you have to recall this for 2 marks. It is asked in your past paper exam. Transverse waves are the waves in which particles vibrate perpendicular to the direction of vibration, or which travels perpendicular to the direction of vibration of particles. Right? It is very simple definition. You have to recall that the waves which travel in the direction perpendicular to the direction of vibration of particles. Right? Similarly, here is a diagram. So that spring is being vibrated up and down. So this would have the vibration of particles up and down, but energy propagation is this way. So this is actually one of the example of the transverse waves. And then we will have some longitudinal waves and examples. Yes, examples are there. Sorry, I was thinking that I have not put the examples over there. The longitudinal waves are those waves in which the particle, motion of energy, or propagation of energy is parallel to the vibration, right? How? Here you are going to vibrate the particles back and forth in the same way energy is being propagated. So there is one important identification, that transverse wave travels in the form of crust and troughs. In daily life, we are having the observation, or we experience these transverse waves. So they travel in the form of crusts and troughs. Okay, Ariba, crusts and troughs. But the longitudinal waves, they travel in the form of compressions and rarefactions. So here, where the particles are very closer to each other, that is called compression. COMPRE double SION, compression. C for compression here, not crest, right? And here, there where the particles have a gap in between, they are called rarefactions.
Sir,
We
can you
will,
please define compression?
yes, compression is that portion where particles are very closer to each other. I mean, compressed form. Compression. Compression mean area or portion of medium where particles are closer. Portion of medium where particles are closer to each other. Particles are closer. Pressure is maximum. Okay, and density is higher. So they all are actually the aspects which you can consider. When particles are closer, their pressure would be increased, and definitely their density would be greater. They are called compressions. So here all these points are compression. Compression वैसे normal daily life का word है कि where a building is feeling compression, or any material is experiencing compression. So distance between two consecutive compressions is called one wavelength, right? What do we call it? One wavelength. Is it? Is it clear to all of you?
Yes, sir.
Yes.
Yeah. Okay. Now we have to write the examples. This is another very important point, that you are asked that highlight or underline the longitudinal waves and transverse waves out of the following. Yes. So electromagnetic waves, all are transverse waves. Gamma radiations, X-rays, ultraviolet radiation, light, infrared radiation, microwave. So that is basically GXULIMR. Jexulimer. Oh, it is just to recall: gamma, X-rays, ultraviolet, light, infrared, microwave, and radio wave. And then water waves. Yeah, we have written an example of. Oh, sorry, we have enlisted that. Water waves. Then sound waves are the only longitudinal waves. Remember this thing. And the waves which are being produced by a spring when it is vibrated back and forth, they are also longitudinal waves. These waves. Okay. So Is it clear? Sound waves and these spring waves, right? So water waves are basically transverse waves, as we know that. Sound wave का पूरा chapter है, so I will not get in detail of that. Transverse waves. In transverse waves, we have two. One of them are water waves, and the second one are electromagnetic waves. We have a complete topic of electromagnetic waves, right? Here we will discuss about water waves. So water waves are basically being produced in ripple tank. What do we call this setup? It is a ripple tank. So when we say that in ripple tank, what are the basic uh, parts of the ripple tank? Actually, those are a light source, illumination. Then we have a power supply to operate this motor. Then we have a wooden rod oscillating pedal, and it is basically hanging with a vertical support. So when you operate the motor, it's very simple to understand that if we have our observation in our daily life, that when you operate a motor, what happens? The motor creates vibration in the water or on the surface. So those vibration would be basically traveling away from the source produced in this way. Okay, in this way, in the form of crust and troughs. So light source which is placed above, actually it behaves like sorry, in the light source, these uh, crust and troughs behave like mirror lenses, right? I will explain that in detail over here, that what happens, the light is being converged by these portions, so it causes a bright line below that over here. So bright lines are observed below the crusts, right? Bright lines. So because there is a line of crust, so you are getting bright lines and dark lines. Check this one out. Here the bright lines are there on the screen, right? So in this way we can observe these formations of crusts and troughs on the screen. These lines are showing the position of the crest. So can you tell me that the distance between two crests is equals to lambda or not? यही होता है ना? So this is basically 1 lambda. So we can measure this distance. This distance will be equals to lambda, and frequency of the motor is being used. So by using this, V is equals to F lambda, we calculate speed of the waves. That's very simple, right? So this is the mechanism how to produce the waves. But now the problem is, when we talk about a wave must have some of the properties. One of them is reflection of the wave. Second one is refraction of the wave. Third one is the diffraction of the wave. So when we talk about reflection of the wave, so for example, if I have water waves, it is basically a diagram, not an image. So some important points are being discussed over here. You have to remember those areas. If I have a wave, ye dekho, that wave is being stopped. Okay, let's say this is stopped. So what will be the behavior of this wave? Will it revert back or not? That one will be reverted back in this way, because you have stopped it. You are not letting it to move on. In the same way, if I place this barrier in this way, and on that barrier I'm going to fall a wave, or I'm going to incident a wave, like this is the line at which it is making an angle look like this. So it would be reflected back, it will be slipped over like this. So if the wave is entering in this way, it will leave you in this way, right? So by considering this all, we can consider, or we can have the reflection of water waves, that if we have a barrier in this ripple tank, this is the barrier in the ripple tank, this one. Okay, this is what, this is the barrier. You have placed a barrier over here. Instead of these waves, I'm going to make, or going to draw a barrier. So that barrier will be basically something like this. it would reflect the waves back, and those waves would be basically, this is the barrier. So what do you think, when these waves are striking to that barrier, will they not reflect in this way over here on that side, because the waves were being incident like this on that one, they are incident like this and they are reflecting back over here. So this is the barrier. So I can simply say that when the waves are striking through a barrier, right, this is the incident wave, this wave is your incident wave, this is your reflected wave, this is your reflected wave. तो होता ही है कि these all are wave fronts. So if I not be wrong, they are crests, is it? है ना?
Yeah.
Yes.
Like
And
top part.
sorry.
Nothing.
Okay, so these are the crests of the wave. So that's why I have mentioned that they have a lambda distance in between and they are moving with v speed. So when they will strike to that, they would remain crests. These all are the crests of the reflected wave, right? This one, and they have the same wavelength. So remember this thing, after reflection, wavelength does not change, speed does not change, frequency does not change. This is the very important key for you people, that during reflection what happens, only direction changes, only direction changes, and direction changes in according to a rule, only direction changes. Okay, let's check this one out, that if this is a barrier, this is a normal, this what do we call it, this is called a normal is a line which makes an angle 90 degree to the barrier. तो आपने ये देखना है कि the angle formed by the incident wave with this normal is same as the angle formed by reflected wave to this reflected wave to this normal. So this is that how do they change the direction? They are not changing the direction by their own. They follow a rule, and the rule is angle of incidence is always equal to angle of reflection. Got it? I will explain the refraction in detail in next
Yes.
lesson because it would take time and you people have your next commitments. Ariba has a class ahead. I have my class as well. So we will discuss that all in next lesson, inshallah. Got it?
All right, sir.
Okay. Any question till now? Actually,
No.
remember one thing. This lesson is not to give you some work from your